Hello everyone. In this video, we are going to discuss about the concepts of drift velocity and relaxation time of class 12 physics from the chapter 3 current electricity. So you see, consider a metal. We know that there are many positive ions and electrons. In metals, these positive ions never perform any kind of motions. These positive ions are always fixed at some lattice point or some point in the metal. And these electrons present in the metal, they move randomly within the metal between these positive ions. So they constitute zero current because electrons are not moving in a uniform direction. One electron will be moving in this direction, another one will be moving in this direction, one will be along this direction, another one will be along this direction. Okay, these electrons are moving randomly within the metal. So the number of electrons moving in a definite direction, that will be equal and opposite to the number of electrons moving in the opposite direction. So they do not constitute any electric current in a metal in the absence of any other external electric field or in the absence of a battery. Now consider we are connecting this metal to an external battery which provides some potential difference V. And you see, so that this end of the metal behaves like, which is like a positive potential, and this end of the metal is having like a negative potential. And you see, because we have connected this to an external battery, when there is no external electric field present here, electrons move randomly. And they move in random directions. They will be having random directions of their motion. So their average velocity will be zero and they do not constitute any net electric current in the metal. But when an external battery is connected, see the directions of motion of these electrons, they get fixed. That is all these electrons. See, we know that electrons are negatively charged particle. This end of the metal, now it has a positive potential. So these electrons will get attracted to this positive potential region. Okay, so all these electrons will be displacing from one point to another point continuously and displaces to one particular direction. And because of that displacement, electrons get some velocity, a non-zero velocity, and that velocity is called as drift velocity. And you see the drift velocity, it is represented like this. V subscript d, which is the drift velocity. See, this drift velocity is the velocity of the electrons which is being offered by the battery. See, we know that when an electric field is present, electrons get accelerated. See, we have this equation of F equals QE and we have this equation F equals MA. Okay, when we equate these two, we can write Q into E equals M into A. Then from this we can write A is equal to QE divided by M. Okay, acceleration is equal to charge into electric field divided by mass. So we know that when an electric field is present, electrons get accelerated. So the acceleration of the electron can be written as Q, it is a charge of the electron, I am taking it as minus E. Then the electric field E divided by mass of the electron. So you see, this is the acceleration of the electron. Now, let us talk about the relaxation time. See, it is represented with this letter tau. You see, the collision of the electrons, they do not occur at regular intervals, but at random times in a metal. You see, we know that in a metal, there are so many positive ions and there are so many electrons. So, when these electrons are in random motion, there is a chance for their collision with the positive ions present here. The collisions of these electrons do not occur at regular intervals, but at random times. So the average time between two successive collisions, that is actually known as the relaxation time. So relaxation time is the average time between two successive collisions. You see, we have this equation of acceleration A. This is a simple equation. Acceleration is equal to velocity divided by time. So here we can take this velocity as drift velocity Vd, and I am taking this time t as the relaxation time tau. So that we can write the acceleration A as drift velocity divided by the relaxation time. From this we can write the drift velocity Vd is equal to A into tau. So drift velocity Vd is equal to A is the acceleration of the electron, which is minus EE by M into tau here. So drift velocity Vd of the electron can be written as minus EE by m into tau, where Vd is the drift velocity, which is the velocity of the electrons which is being offered by the battery, minus E, which is the charge of the electron, capital letter E, that is the external electric field present here, small letter m, mass of the electron, tau is the relaxation time. So in this video, we have discussed about drift velocity and relaxation time. I hope it is clear to you. Thank you.